So in the graft there is a restriction mainly in the graft tissue. The leaf area is smaller in dwarfing rootstocks. Might it cause that they have better regulation of the water regime, and in drought condition, leaves of dwarfing rootstocks were abscessed in higher rates. So it's in the relationship with the terminating of the growth. For the references, I would conclude that there are some uncertainty in the results because the trials were done in different conditions. It was spot and field trials. It was 23 different studies, and they used different rootstocks in the trial. So as I said, it's not possible. Probably it's not possible to do some broad general information for the group of dwarfing, semi-dwarfing, and vigorous rootstock because, for example, the different root system, different larger root system could make different conditions for the plant, and not many references have different water irrigation treatments. So these different treatments could also have some significant effect on the rootstock growth. So that's all. Just brief review from the references from our table. So if you have some comments or questions.
Can you go to the conclusion section? Yeah.
This one?
What do you mean by better water supply regulation? I don't understand this.
But yeah, you mean here. I think that it's because of the stomata that they have smaller but denser stomata, so they can promptly reply to the drought, and might then they can have better regulation when the drought is coming.
Well, why you indicate leaf area, Muslim? Leaf area is smaller.
Yes. The
more indicated.
The leaf, because the leaf area is smaller, then the gas exchange is not so broad, so then they can regulate it better.
In fact, smaller trees have also smaller leaf areas as the tree.
Well, say exactly the small size stomata and the more stomata.
It's for the dwarfing rootstocks. That they have lower leaf area and different stomata density and
density.
Okay. Thanks for the presentation. I just wondering the fourth sentence. Incorporated rootstocks have higher water consumption, and it leads to larger stomata, or larger stomata leads to high water consumption.
Yes, it could be also the both way. I found in the literature this definition.
I think the larger stomata leads to water consumption.
But it's also bigger tree, bigger leaf area, higher transpiration rates.
No, I mean for human trees consume water, more water consumption. It leads to larger stomata. Or larger stomata, if a tree larger stomata, the tree consume more water.
Yes, it's I've written it not right way.
I think those things are closely connected because if you have large stomata, you will
But the more transpiration.
Yeah.
it's more transpiration.
Yes.
But if you don't have enough water, probably will be the trees. It's I think it's similar like in the more invigorating cultivars. The barking rootstocks are connected with lower effectivity and but from the regulation of the water consumption. So I think it is similar like this, but those two things I know what do you mean that
Yeah.
if the stomata are the results or the primary effect.
Yeah, I mean, yeah.
But, I don't know. I think if the plants had better regulation, that tomata would close earlier, and so it's hard to say. I think.
Dependent also the open side, the open degree of stomach. Maybe more full out of.
Yes,
Also-
I think I've used not a good way how to write it or how to state it.
Anyway, all these statements
But
are
it's
coming from the
connected.
literature.
Yeah.
One question from the online.
Mhm.
Alpha, please.
Okay, just a curiosity. Thank you for the presentation. The work that you show with hydraulic conductivity, the age of the plants is about so the age, it's all the trees or very young trees?
You mean this one or this one?
No, the hydraulic conductivity in which you present a little bit after, later. Yeah, here.
Here.
Yeah.
It's just the rootstock. Just no. It was the tree, but I'm not sure how was the trees old. I think it was just 1 year old.
Okay.
But I'm not sure.
Yeah, so we have to, okay. So now I understand a little bit better why the graph junction, it's a little bit different because it's, for this graphic, it's a little bit strange for me that the stem hydraulic conductivity is very high in dwarfing rootstocks when you are saying they close their stomata, they close more their stomata. You know, so, and
I
we
don't
have
close more, but they have different size and different density. So
yeah, I'm a little bit afraid that here we have the effect that the graph junction is not complete. Sometimes it happens. Okay, so, and another suggestion, I'm not a specialist in apple, but I remember years ago when I was a student, I was very interested in the work of INRA in Avignon from Robert Habib. He works a lot in invigorating and dwarfing rootstocks and the part of root patterns growth. So what he did, he spent a lot of years looking for the pattern of growth of the roots, and basically they showed that the pattern is different. So they begin their growth earlier, and then they expand their root in different times than the other rootstock. So they can help a little bit to understand why we see some differences when we are applying deficit irrigation, at least. I don't know, just a suggestion, okay?
yes, okay, thank you. It was just the part of the literature that we.
Yeah, it's very old literature. You have to go to late 80s. So these works are in INRAM Avignon, it's okay, very old work, but I think it's very interesting because Avignon, they are usually work on modeling, and they did some models for the rootstocks.
Okay, thank you. Yes.
Actually, it is very interesting. Thanks for this presentation, Clara. Dwarf leaf, with low area, when we talk about this, they are growing in high light condition, for example. So physiological point of view, photosynthesis point of view, we say that, photo inhibition, there is a photo inhibition, our leaves can be inhibited photosynthesis continuously, probably. So it could be very interesting also to connect, these things with physiology of the leaves, how it works together.
Mhm.
Then we will have a kind of whole picture, water regulation and plus physiology.
Okay.
To me, this graph is really interesting because if you check the units, it's normalized by the surface. So it's saying that the lineal section of each element have different conductivities, meaning that the Scion, the M9, the Darfing one, has a very low root conductivity compared to the others. So maybe the root and the root plus the grafting area is the one that is determining everything off. And it's conditioning all the things, the leaf area,
Yes, that's the way how it works with the drought or with the irrigation and with the growth of the bark.
And I have another question regarding this graph. Do you remember how they measured that?
I think they used some kind of colorant, the saffronin or something like that, for measuring. But I'm not sure how was it done. I remember that they cut the part from the rootstock, from the graft tissue, and from the stem, and they measure it underwater, and then they they assessed the smaller parts of the rootstock and of the scion stems.
It kind of be. If you are putting megapascals in the units, you have to apply pressure somehow.
Yes, they.
No,
I-
just
Sorry,
no.
I don't know.
No. Well, any other questions? No, thank you very much for nice presentation. And I would like to ask Radmila to speak about the rootstocks for here and the water requirements.
Once more, Martin, thank you for the announcement. This time I'm talking in the name of Econ Peer Group. And as Martin said at the beginning, irrigation and water requirements are very dependent on many factors. But in this presentation, I will try briefly to explain how rootstock as individual factor can influence peer trees, with particular approach to water requirements related to fruit quality, fruit yield, and tree vigor. Various studies highlighted significance of rootstock selection, especially in arid and semi-arid regions where pear is grown. And unfortunately, I don't have my own experimental results from Serbia. As a participant on this project, I learned a lot about this. I didn't have much experience in this issue, so I hope in some future time I will come to you with my own results and results from Serbia. And I have to say that peer isn't as interesting between researchers as apple is, and so there is not much related results. Pear is very important fruit species in the world. It is a worldwide fruit species, and it is in the apple group. It is immediately after apple, with production of that exceeded 23 million tons per year. The biggest producer is Asia, with 70% of total world production of pear, and Europe has only in Europe, we produce only about 14-15% of total world production. And among countries, China is the largest producer, followed by USA, Italy, Argentina, Spain, Turkey, South Africa, Japan, Republic of Korea, and Belgium. In recent years, in pear orchards, as many fruit orchards are confronting with climate changes and decrease in rainfall, so there is a need to find some alternative method to solve this problem. Actually, there are many irrigation strategies and methods that can successfully solve this problem, but in arid and semi-arid regions, we have to really find some alternatives. And using drought-tolerant rootstocks in pear orchards would be a very successful alternative for solving this problem. So the aim of this investigation is to study and investigate the impact of different rootstocks on pear water consumption, water use efficiency, fruit quality, tree vigor, and yield. Water has large requirements. Pear has large requirements in water, not as apple, but it is still large. And the amount of precipitation between 5 and 600 millimeters per year could be enough for pear growth, but in the region where pear is grown, mostly those precipitation are not properly distributed. So particularly, we can't imagine pear production without irrigation and enough water supplyment. As a fruit of exceptional importance, pear really requires a very specific approach to cultivation technology, and water supplyment is vital for pear trees. We all know that water directly influences fruit quality, fruit yield, tree vigor, and overall productivity. And it is in pear trees, it is particularly important during main developmental phases such as flowering, fruit set, and fruit enlargement. And we know that if there is not enough water in that period, we can't expect satisfactory yields or quality. And there are many literature data that say that besides external fruit quality, water significantly influences internal fruit quality, such as concentration of sugars and total acid. Also, water is very important as to make significantly influence tolerance to pests and diseases, because the drought stress can significantly weaken pear trees, and they are more vulnerable to pests and diseases such as fire blight in pears. And finally, water is necessary for normal nutrient uptake from the soil. On the other hand, choice of rootstock when established in pear orchards is very important and one of the most important things. And there are many studies that emphasize the importance of rootstock selection, especially in the regions where there is a lack of water. And for example, in semi-arid and arid regions, it is very important to choose adequate rootstocks which can save water in orchards significantly. So what I want to emphasize is the thing that really choosing a rootstock should be correlated to agroecological conditions, especially with soil type and water availability in this region. There are many rootstocks for pear, and most European pear cultivars are grafted on Pyrrhus genus rootstocks, such as Pyrrhus communis, Pyrrhus betulifolia, Pyrrhus pirifolia, Pyrrhus scalariana, and slično, and similar. And some of them are grafted on queen's clonal rootstocks, such as Queen's A, Queen's C, Queen's Adams, Queen's C, Queen's BA29, and etc. And all those rootstocks are differing between each other in architecture of root system mostly, and some of them have deeper root system, which allows pear trees to take water from deeper soil layers, and the other ones had more shallow root system, which limits pear trees to take water from surface layer of the soil. And that means that different rootstocks have different water use efficiency. For example, Pyrus communis, a rootstock has deep and large root system, which allows pear trees to take water from deeper soil layers, which is very significant during drought stress. And on the other hand, Queen's rootstocks are having more shallower and smaller root system. Root system of Queen's rootstocks is more dense, but it is concentrated only in the surface area of soils. So pear trees on Queens can take water immediately from the when we apply the water, but it needs constant water supply. In some literature data, can be found that rootstocks for pears can influence stomatal closure and opening. And as Clara said, some are pores on leaves that opens and close in accordance to water availability. So some pear rootstocks can influence that opening and closing. For example, I found in literature data that Queen's A rootstock produce more significantly influence producing a hormone of citric acid, which directly influence and signify to stomata to close during of lack of water. And that way, this rootstock can indirectly influence and save water during transpiration and not affecting photosynthesis. So those rootstocks have a better water use efficiency than the others. Fruit quality is directly related to rootstock, but also rootstock indirectly through water availability can influence fruit quality. So there are many results, but I choose a few. Rootstocks that improve water uptake efficiency by developing deeper or more expansive root system can ensure that trees receive sufficient water even under drought conditions. Also rootstocks that promote efficient water use without excessive vegetative growth can help concentrate sugars in the fruit. And also some rootstocks can affect the appearance and texture of the fruit during water stress and lack of water. Rootstocks that ensure consistent water supply can maintain stable yields even under fluctuating climatic conditions. There are many indirect influences of rootstocks and water availability that finally influence the final pear yield. So the rootstocks that have a deeper root system and better stomatal regulation can help ensure that trees continue to produce a stable yield. And water that influence the better water availability can enhance flowering and increase the percentage of fruit set, which finally influence the yield of pears. Also, there are findings that say that rootstocks, drought-tolerant rootstocks, mitigate the negative effect of water stress on yield, and which finally translates into higher yields in pear orchards. And the relationship between rootstock, water use, and tree vigor is very known. So rootstocks that have deeper root system take more water in drought periods, and those rootstocks can influence more vigor canopy. So in this case, we should be very careful with balancing vegetative and generative growth to finally have a good quality and good yields of pears. And also there are many research findings that make comparisons between different rootstocks for beer and their water availability. For example, the higher draft susceptibility of CIDO in comparison to Adams was observed in Edda-Fatal beer, or in many research results is emphasized that Pyrrhus genus rootstocks such as Pyrrhus communis, Betulifolia, and etc. Had better bigger tolerance to draft in comparison to Queen's rootstocks. There are also findings that CIDO rootstock had higher sensitivity to water stress in comparison to BA29. And also there are reports hard dwarfing rootstocks generally show higher decreases in stem water potentials when subjected to draft stress due to their lower hydraulic conductivity. What I want to emphasize is the fact that the effect of rootstocks on water use, fruit quality, and yield are also influenced by specific cyan cultivar use, and not all rootstocks are compatible with all cyan cultivars, and the interaction between the two of them determines the overall performance of the tree. For example, a rootstock that improves drought resistance for one field cultivar may not have the same effect on another. This is also one very interesting research which was focused on Edda-Fatal beer. Trees grafted on two different rootstocks, BA29 and CIDO. And in this research, they were irrigated using three different regimes. And finally, the result showed that CIDO rootstock as more dwarfing rootstock had higher sensitivities to stress in comparison to BA29. So the study suggests that deficit irrigation can be used as an adaptive strategy to optimize water use and improve fruit quality, especially for vigorous rootstocks like BA29. For dwarfing rootstocks, in this research CIDO rootstock, reduced irrigation requires more careful management due to the higher sensitivity to stress. And for the end, I would like to make a few conclusions. Rootstock selection is a key determinant of water use efficiency in pear trees with significant implications for fruit quality and yield. By influencing the root system architecture, stomatal conductance, and overall tree vigor, rootstocks play a central role in how pear trees utilize water, particularly under water-limited conditions. The right rootstock can enhance water uptake, maintain yield consistency, and improve fruit quality, making it a critical factor in sustainable field orchard management. Balancing water use with the desired horticultural outcomes is essential for achieving high-quality, high-yielding field orchards, especially in the face of decreasing water stress. And thank you for attention.
Thank you, Radmila, for a nice presentation. Do you have any questions? If not, we can continue for the last presentation of this day. So I'd like to ask Natasha to present the
This is the week slides.
next slide.
Makes laser. Okay. First, thank you for inviting me, and thanks Radmila and Jelena to ask me to join this group. I have experience on crop physiology and irrigation different crops, but I didn't work with strawberries before. So it was a challenge for me how to start to work on this crop, and it took me some time. And until today, I was thinking that I'm nearly to finish, but I got so many nice inputs today from everyone, from their work. So maybe some new ideas to add in the review paper. So I did some activities to find papers with some keywords that were needed related to crop irrigation scheduling, evapotranspiration, water use, drought, climate change, smart decision support system, and so on. And there were plenty of work that has been done, but also different results and some things that I couldn't understand. So I was trying to find the papers and try to think how to present the work. When I was reading, I was thinking also what eventually profit could be out of this article, not just for scientific community, but also for farmers, because this crop is widely used and farmers need to step up from some ordinary practicing irrigation scheduling. And nowadays it's more about precise irrigation and use of different smart tools. So we need how to understand how to help farmers and how to optimize water use and also reduce environmental pollution, because strawberries are very well known for use of fertilizers and a lot of water. The structure of the paper looks like this at the moment. It will be about the main information about the crop, and it's very important to understand the crop growth cycle. And if this is in general a perennial crop, but normally it's used for 1 year for the faster production. So we also need to know about irrigation management, because the crop is grown in different condition, either field where we have mulch or no mulch, then we have plastic tunnels, and also we have greenhouse production, then different soil condition, and also soilless condition. The most important maybe is not, but for me, because I did my master thesis in crop coefficient, it's this information about crop coefficient and how does it change from 56 and how could be improved. Then about strawberry water use efficiency and new approach in with the decision support system. When we look at the crop growth cycle, you could see on this photo that the crop has this cycle, and the most important part for thinking about irrigation is flowering time, and also after the harvest, because here it's crop it's flower initiation for the next year. Of course, during all the period, there are irrigation that has to be optimized. It has to be optimized because the strawberry has a really shallow root system, and also doesn't tolerate more water, doesn't tolerate no water. Also, it's problem when it's over irrigated. It's important crop. It's high value crop, has a lot of benefits, a lot of production worldwide, and its production influenced also by climate condition, by genotype, by needs of the market. So it has to be. We have to think about all different aspects of growing strawberries, and of course where we are growing them in order to think about the optimization of irrigation. As I said, there are some important key factors in irrigation scheduling, like crop growth stages, flowering, fruit development, and fruiting, and they all vary in crop water needs and demands. I already mentioned this frequency of irrigation also depends on the soil type and texture, climate condition for evapotranspiration, and the type of irrigation. Here it's on this slide. I could not say all, but somehow we need to think about the soil structure for the soil water holding capacity. And then we have to think if we are not having lysometers, but we don't have on the field where farmers are going, we have to think about reference evapotranspiration. Reference evapotranspiration are often calculated by input data from the weather station that we have. And normally it's used Perman-Montit equation. However, there are a lot of different equations, and in the lack of some of the parameters, some other equations that are using only temperature data, like Harvey-Semani, are used. This reference evapotranspiration and crop coefficient are needed to define the crop water requirements, and actually for net irrigation requirement. Net irrigation requirement is crop evapotranspiration that it's taking in account also effective rainfall. When gross irrigation requirements, it's depending of application efficiency, depending of the system that we are using. Okay, so here it's a lot of question, because when we look on FAO 56, we have a big table for all the crops that are used for the crop coefficient, and we also have crop growth stages for the crops. As well, we have also for the strawberry crop coefficients. There are a lot of revision that has been done, mostly from University of Lisboa, with Paula Paredes and Luis Pereira, and they did a great work to compare these results from the 90s to nowadays, and it's obvious that crop coefficient has been changed. Crop coefficient, it's a normally ratio of crop evapotranspiration and reference evapotranspiration, and identify the crop that we are using. It's depending on a lot of things, like breeding techniques. I mean, one cultivar, it's not the same like other cultivars. Management techniques, the crop coefficient is not the same if you're going in mulch or without mulch. Weather condition, calculation of a reference evapotranspiration, and that's I was using. I was taking into account when I was looking for the papers. These values here in the middle are proposed for the single and for the basal crop coefficient, for initial, for mid-season, and for end season. And these values are those that I found in the literature. You could see, for example, for this mid-season that it's a little bit out of the range. Some papers are published like that. We have to find out why. But it's important to evaluate all these papers and to see what is going on. I have made a table, like a big table with all the management conditions, and with field studies, plastic studies, and greenhouse studies. And the first information was this FAO data from the FAO 56, and then I used the published work that has updated data. Then I try to see what is going on in the paper that are published. I had talked with Paula Paredes, and we agreed that, of course, we had to distinguish the management system. We have here field condition, and one of the way to calculate crop coefficient was based on the linear relationship between crop coefficient and canopy coverage, because the crop, it was found that crop coefficient increased together with crop growth and vegetation. Based on this coefficient, it has this formula could be taken into account. Then the other work it's with plastic mulch, and there is a difference in crop coefficient because you could see also that it was used canopy coverage way of the previous work. So, but the values of crop coefficient are different. In study that has been done on melon, we find out that under the same climate condition, because this study and the previous photo are not the same, but we had in Italy this condition of mulch and non-mulch, we find out that growing season is for mulch is shorter, evaporation is lower because it's covered, transpiration is similar, evapotranspiration it's lower, mid-season transpiration it's greater, and crop coefficient mid-season is greater. So two different cases, and you think it's on the field is the same, but it's not the same. Here are values by weeks how for the crop coefficient in this work. Then in plastic tunnels for two different cultivars, we have different crop coefficient values. Sabrina in mid-season has 1.1 as a maximum until a 0.8 maximum. And I think for Sabrina, the yield was higher also. When it comes to what I found in this work, they stated that growers are not likely to use crop coefficient on canopy coverage because it's difficult, time-consuming to estimate, and they like to use crop coefficient expressed on a time basis or growing degree days since planting. So here on the third slide, you could see crop coefficient expressed as a growing degree day. That also work. We tested on a tomato in previous work. Okay. For the greenhouse condition, I found two studies, but the other one was a little bit strange because it showed all the time crop coefficient 1.1. So I didn't take it into account. This one, it's work from my colleague from Aarhus University. We actually were seated together in the office when I was working on my PhD. So it's work from the greenhouse, and he was doing optimizing the irrigation, taking into account different strategies for electrical conductivity. He found that of course, irrigation regimes increase the fresh fruit yield, berry class, biomass, and leaf area, but the content of sugar and acid increased with increased electrical conductivity, but decreased with evapotranspiration. And here are the crop coefficient from the greenhouse that he used. What is also important to say that on the field condition, precipitation having an important factor in determining evapotranspiration and crop coefficient, but in this protected area, there is no a case. Some tables that I have prepared are also for the total strawberry water requirements, and there are a lot of work, and I have presented here just values from different countries and for different cultivars, mostly used by drip irrigation. Some of them are with mulch, some of them are without mulch. You could see that the values are from 300 to 700 millimeters. So a lot of different range of strawberry water requirements. Some of the work are older and some are like from the new studies. For the tunnels, more or less it's similar output for the crop water requirements, and is 350, 400 millimeter for the total growing season. And for greenhouse condition, we have interesting work. The first one that determining of the total crop water requirement was depending on the method for calculating reference evapotranspiration. And that is the first work from Spain. So you could see if they use macking or measure the radiation, it was different. I think also it's the first part. It's the data that the weather station was outside, and the other one it's when they were inside. And from this work from the greenhouse, I think it's for the 84 days he had this total strawberry irrigation requirement. And then in China, for the drip drip irrigation in the plastic greenhouse, this output. I was also looking on water use efficiency to see if there is any difference in water use efficiency, and I have found one work where 3 different cultivars were compared, and it was shown that this El Santa has in stress condition higher water use efficiency, and that means that water loss it was restricted earlier and more intensely than inhibition of photosynthesis. As I said at the beginning, it's very important to know how to help growers and farmers, because on-farm irrigation efficiency is less than expected, and they don't perceive the moisture in the soil. So they either over-irrigate or not irrigate enough. At least that is the case in Bosnia. We have recently one project on agricultural water management, and we are in lack of equipment and things to optimize water conditions. So we are basically looks like we are working from the scratch. So farmer decisions are based on their own experience, observation of weather condition, and visual indicators of soil and plants. Also there is a point about fertigation cost and that are affecting not only water use but also pollution. And in recent years, most of the land on which berries are grown has been declared vulnerable to diffuse nitrate pollution. I got from Professor Paula this Riego Berry mobile application, which I think it's super cool. It's called a powerful tool to improve on-farm irrigation performance in berry crop. It's not just for strawberry. It's for different crops. They were in this work. Gavilan, they did, I think, more than 100 greenhouse testing experiments to improve this application. And it's but the problem is that I couldn't download it's only now for the Spanish growers, so I couldn't see how it works. But they stated that it's based on FAO methodology for meeting crop water requirements, and that use weather forecast, soil data, irrigation system characteristics. They found out that this application could save 41% of water and could be easily used by technicians and farmers. And it could be also transferred to other countries. As I couldn't open this application, and we had the previous work on maize, working on irrigation tool by Professor Mladen Todorovic from CHM, Italy. I just want to show you how does it look. I guess it's similar to one that they use for the strawberry. Of course, this one could be used for strawberry. So you need just some input data when it starts your day of planting, and here you have some information about the crops, about the root, T-base, then the different stages of the crops, following by crop coefficient, some information about the soil, and some other information that are needed. For the irrigation by these tools, we needed to follow soil moisture. We didn't have some fancy tools, so we used this gravimetric model, and we had the three different irrigation methods, and management of the irrigation we followed by Blue Leaf from Italy, one application also. So we in advance knew it, how it will be weather prediction. And this is just the output of different water strategies to see how does it look the day by day the water in the soil. But it's good that these things are really easy to be used, and if you have some good weather station or weather prediction, you can optimize your irrigation and manage your irrigation. For some conclusion of the review paper, I will put that effective irrigation scheduling is essential, and it has to be understood under varying management and climate condition. Significant advances are needed because we need to understand tools for efficient irrigation, and also we need to improve some work, and that's a lot of to be done for the environmental impact and optimizing environmental impact together with irrigation and fertilization. And we have to develop a really easy, user-friendly decision support system to help farmers and to help all of us to save water in this changing climate condition and increase water scarcity. I would really appreciate some comments, because I think there is a lot of things now to be improved. If you have some suggestions, then I would be happy to accept. Yeah.
I have one. It's not a suggestion, sorry.
Okay.
It's a question.
Yes.
In the mulching slide,
Mhm. Okay.
Yeah. In that, in the table where you have parameter, under mulch, no mulch,
Yes.
you have under mulch a shorter growing season, lower evaporation, similar transpiration, but then the Kc in its season is greater.
Yeah.
Why is that? Do you have any idea?
It's we because the evapotranspiration.
But if evaporation is lower and transpiration is similar,
Yeah, because of the evaporation.
that shouldn't be lower.
Evaporation.
I'm just asking. I don't know. In my opinion, it should be lower, but maybe it's because the.
In my experience with strawberries, then if you grow strawberries on black mulch, the overheating of the culture is much larger than in the free
Then
soil.
transpiration should be higher.
Transpiration should be higher because it accelerates growth. Sorry, that was that I have to.
So
yeah,
it's like
yeah.
I
Thank you.
And
I have to correct that.
no, it's just maybe there was another reason, but
yeah.
And one suggestion is that I really, well, it's not a suggestion, sorry. And
Okay.
it's the table where you showed all the KCs.
Yes.
I think that's very useful.
It could be useful. What else I found related this mulch? They found out that under red mulch, the fruit quality is better.
Ah.
So, but normally they use the black one.
It is that the black foil better covers against the weeds.
Yes,
But,
the weeds and also to
indeed,
retain humidity.
The overheating of the plants includes also the fruit, so the
Yeah.
quality also suffers for
Yeah.
that. Any other questions? I think the presentation is very nice, and I would like to read the
draft.
The draft in order to learn something new.
Yeah. When we decide, we separate for the crop, but we are constantly on consultation. So the thing is that first I will give to Jelena and Radmila to read, and then you will get it.
No problem.
But I think I should, because there is a lot of data and it's complicated because there are a lot of cultivars, there are a lot of studies. So it's a little bit difficult how to interpret them. So I still need, I think, a little bit more work, and then I would be happy if a group of people could evaluate, because I think it's needed.
How about the link of the KC with some physiological?
That could be interesting, because yeah, at the end it's all about how different cultivars perform. I did that for the black currants, totally physiological study, and I found out that they are tolerate different drought stress, but also temperature stress. So it could be interesting to connect. I didn't want to put physiology, but I could add it for sure.
It's up also to the size of the review paper, because I have presented a lot of information. If you had included all of these things, that
I should think about how to make it clear, but still retain all the information that has been published. Some works I took out because some data are not reliable. For some reason are published, but I don't know.
Natasha, Martin, can I do a question?
Yes.
Sure.
Okay, so I congratulate you, Natasha, for so big amount of data that you bring to us. It's very interesting, and I think it's really a challenge to combine all data. I was wondering, you talk about that fertigation costs are very low. Do you have eventually a table where you could really put the cost related to water, to watering, to fertilization, uh, um, uh, pesticide treatments, um, um, and labor? Is that possible also to have that information? And the other thing is that maybe of course, as you have so many data, I don't know if in the publication you can put some of the summary tables that you built. I think it's really interesting to have tables that resume information. Maybe you can put it as additional data in a publication to not to make the central paper very big, because it's then very difficult to read.
Okay.
But maybe some of these tables and combined data maybe can be in supplementary tables, yes, or supplementary data sources. Maybe it can be a solution to minimize the problem so many data. Thank you.
Okay, thank you for your suggestion. It's great. And for the economic cost of the fertilizer and water productivity, I should also look. It's a very good idea.
It's a good idea, but really hard. It's
Yeah,
the economics are so local that depending on where you, water prices and fertilizer prices are so different across
That is true.
this that it's very hard. You can do a case study of it someplace where it's interesting, but it won't necessarily be representative.
Actually, a colleague of mine, she did in master cycle assessment, and from Bosnia for the maize experiment. And yeah, we have to use the local costs. I mean, I was preparing some of the data like yield, and then I was looking how much is seed, how much is, and yeah, that depends locally.
But the tables that you elaborated for the cases, that must be included. This is going to be like a reference for the, but it's a good reference in your paper, and it's going to help the review. And people is going to look for, when people search for strawberry KC, they're going to look to that type of tables. So that.
Okay. Okay. I hope this work will be out.
You've done a great job. Can you expect to submit that?
Now I don't know, but let's see the next 2 months, because I also changed the job, so I have to show up on the work. But we will work together, and
don't feel depressed, but
yeah, I think it's feasible. And then can easily do it on black currants because it's tricky crop, strawberry. It's it's different management conditions, and yeah.
So
if you are cutting after harvest strawberry, there is no the late stage crop coefficient, but and also no irrigation. But if you are saving like perennial, you have to think all the time what is going on. I mean, for the flower initiation, and also you have to think during this chilling period. Nowadays with climate change, it's very difficult to manage production. Yeah.
We are all looking forward to look up for that paper.
Okay.
Well, thank you very much.
Thank you.
There are no other questions. Yeah. Now we are almost at the end of our today meeting. So if you have any questions or ideas for discussing any things what you have heard about this day. So feel free to mention what you want.
I have a very general request from the community. We use the terms water use efficiency and water productivity, and we mean all kinds of different things. And the only one today that gave us the definition, Natasha gave us her definition, we could understand what it was. We have to, every time, my request is, every time we use the term, especially water use efficiency, define it, because there's too many different possibilities and they mean very different things. And we should go towards water, when we're talking about yield as a function of irrigation water, it should be water productivity. People have suggested that in the literature, and I think it's a good idea. Right, so probably yours would be better if we called it water productivity. Although you did a good job of at least defining it, whereas some of us today, it could have been carbon as a function of transpiration, right? And it's really not clear. And especially when we're doing literature reviews, we have to make sure that we're talking about the same terms. It's important, and we're all over the place. Just a statement from it.
Okay.
One thing related to water use efficiency. Well, in my case, it will be water productivity, define it as yield versus ET. It seems that the Dorfin rootstock just reduced water potential and have greater hydraulic conductivity. So my point is, from the water productivity standpoint of view, might produce the same effect as a deficit irrigation. So if you are a farmer that have water and you want to save water, but you don't want to apply deficit irrigation, you can say use a Dorfin system and you are going to have a higher water productivity.
Ooh, I think this is a quite complex.
So it should be a compensatory strategy. So if you have water, use a Dorfin rootstock because you are going to save water without doing anything. But if you don't have enough water, you should go for deficit irrigation strategy. So this Dorfin rootstock, you might not need it because the stress effects are going to come from the irrigation strategy and not from the Dorfin roots.
Then you would use regular
deficit irrigation to achieve the same goal, maximizing water productivity.
You need to go tightly along the climatic conditions, because if you do this on a very warm and dry conditions.
No, it doesn't matter. It doesn't matter. If you are in the same environment and one have water and the other one hasn't, the one that has water and want to maximize water productivity can go for a water product. It's an hypothesis for Dorfin rootstock, because it's Dorfin rootstock is going to lower water potential on its own, and it's going to reduce the transpiration and the canopy. The point here is that if you are using a Dorfin rootstock and you're increasing the plant density of your orchard because you know that the Dorfin rootstock is going to be smaller, does it compensate at the field level or not? Probably not.
Yeah. I think you forgot another factor here.
Which is
that dwarfing rootstock, you need to increase your fertilizing. So they are not able to extract all the element from the soil like the vigorating one. So you are gaining in water, but
Moreover, you can have problems, for example, with pears. If you use dwarfing rootstock with slowly growing cultivar, the compatibility of and the, let's say, longevity of the orchard and the fertility of the trees can be affected. So this could harm your ideas.
Okay.
Well, any other ideas or suggestions? Maybe we can focus the discussion also to elaborate a little bit about the ideas for the review papers and maybe some suggestions for younger students or people younger who are reading or let's say try to the team for particular crops to be also interesting. Found any idea about that? What did you hear about the strategies for the writing? Could be also an interesting interaction.
I think we are quite done for today. So
Well, okay.
to use tomorrow morning would be a better way of.
Tomorrow we will have again some space for any kind of discussion. So feel free to continue with your ideas and with your suggestions. So yeah.
Yes.
Something about the program. Now we are finishing for today, and we should go to the dinner. If you want to join, it is open for all, and maybe where we could have a meeting point.
Maybe at the rectorate, maybe close to the rectorate.
If we would come maybe on 3/4 7, it's quite near here in the at the rectorate. We will meet together, and the restaurant is, I think, 10-15 minutes from the university, so we can go by feet. Okay.
What time? 7?
The reservation is beginning of 7 o'clock, so arrive
We
at
meet a
time.
little bit before, a little bit earlier than 7.
But yeah, we can maybe come a bit earlier, but I wanted to give you floor to
Just
cool
to
down,
relax a bit, yeah.
relax with
To come 6:45.
6:40 is okay.
6:40, okay. Great. Okay.
I don't understand where.
In front of it.
Yes, that I think.
Fast.